Everyone, in this video I would like to talk about Address Resolution Protocol or ARP. In network communications, any two devices that they need to communicate to each other, they need to communicate over layer 2. It means, for example, if PC1 wants to communicate with PC3, PC1 needs to know the layer 2 address of PC3. The layer 2 address is the same as physical address of PC3, which we call it MAC address. For making this possible, address resolution protocol is going to help to PC1 to earn the physical address of PC3, because in the beginning, PC1 does not know the physical address of any other devices. To show you this, I'm going to go first of all into the command prompt, and I'm going to show you how we can see what is the ARP table instead of PC1. Means which physical addresses PC1 knows. So for that, I will write ARP-A. As you can see, there is no ARP entries. So it means PC1 doesn't know any physical addresses in the network. So let's make an entry. There is a possibility in packet tracer, which is not in the real life, that you can see the different processes in a step-by-step basis. So if you go to the simulation tab in the packet tracer, you can see the pings or the different processes that you do in network in a step-by-step basis. So in the beginning, I would like to change my filters. So by pressing show all none, so I'm going to delete all the filters which is available in the simulation section. So in the filters, as you can see, we can see different processes for different protocols. These are all different protocols that we don't want all of them. So that's why I'm going to select none of them. And I'm going to edit my filters. And in order to edit my filter, I would like to just see the process for a simple ping from PC1 to PC3. So for that reason, I know that PC1, in case wants to ping PC3, he needs to know the address of PC3. So I need to know what is happening in ARP protocol. And also in ping, we want to know what is happening in the ICMP protocol as well. So I will select these two and then close this tab. So as you can see, my filters, ARP and ICMP is shown over here. Close it. And now is the time to ping from PC1 to PC3. So I will go to PC1 and I will write ping 10.0.0.3, which is the IP address of my PC3. So I will press. So if I was in a real-time section of the packet tracer, I could simply see that the ping are coming. However, right now I see two packets besides PC1. The reason for the two packets is PC1 doesn't know the physical address for PC3, so he needs to create an ARP packet first of all, and after he knows the address of PC3, he needs to create an ICMP packet. So we will click fast forward, so we will see what is going on with the communication between PC1 and PC3. So we will fast forward one step. As you can see, the ARP message came into the S1. So we can check this packet by double clicking on that. So as you can see OSI layer for this packet, and as you can see input packet data unit and inbound packet data unit and outbound packet data unit. So in the inbound, you will see the packet which is coming from PC1 to S1. So if I go to inbound PDU details, I will see more details than in OSI model. So I will go to inbound PDU detail in order to see what is inside of the packet and what PC1 basically is sending to S1. I will take a look at the layer 2 header. As you can see, the Ethernet side is going to be the layer 2 header in the packet that PC1 is trying to send to PC3. First of all, we stopped it on S1. So as you can see, the destination address that PC1 used for PC3, as he doesn't know the destination address of PC3, is all F. All F means PC1 wants to send this packet to all the devices into the network to see who has 10.0.0.3 IP address. So there is an ARP header in this section as well, as you can see over here. As you can see, the target IP is the IP address of PC3. And the target MAC address, since he doesn't know, PC1 doesn't know about the MAC address of PC3, is all zeros. And source of IP is the IP address of PC1. So these are the information that we got from the packets that this PC1 is trying to send to S1. So I'll close this one. Then I again forward the packet. As you can see, since we saw the destination address was all F, it means this is going to be broadcasted to all devices. So it got broadcasted to PC2 and the switch 2, but not through the ingress port because S1 received the packet through fastener 0/1. So it's not going to send it out through fastener 0/1. So it goes through the egress ports. So again, another step, as you can see, again, is going to be broadcasted. So PC2 and PC4 are going to reject it because that packet is not for them, because the IP address of 10.0.0.3 does not belong on PC2 and PC4. However, PC3 received it, and PC3 is going to bring it back all the way to the PC1. This time, we didn't see any broadcasting happen of this specific packet because PC3 right now knows about the MAC address of PC1. He learned it through the packet that PC1 sent it out to PC3. So if we continue, you see it's the turn for ICMP right now. ICMP is going towards PC3. However, this time is a unicast communication because PC1 knows the MAC address of PC3. As you can see, the ping was successful. This check mark means ping was successful. So I would like to go to the real-time scenario, and I would like to see what's happened. As you can see, this is our ping, and I would like to know what's happened in the ARP table of PC1. So simply I will say ARP-A. In ARP-A, I can see the ARP table of PC1. And yes, here we go. I can see an entry, and the entry, as you can see, the IP address of 10.0.0.3, which belongs to PC3, got resoluted to this physical address. And that's what ARP does. So as you can see, that PC1 dynamically learned this physical address. So let's go to PC3 and see what's happened inside of ARP table of that PC3. ARP-A. As you can see, PC3 knows about physical address of PC1 as well. And for sure, it learned it through the packets which was sent through PC1. So this is the IP address of PC1, and this is the MAC address of PC1. So in case I want to ping from PC3 to PC1, and let's try it out into the simulation, and I have the same filters, but this time I want to go to PC3 and ping 10.0.0.1. As you can see, we have only one packet because we don't need ARP, because PC3 knows the MAC address of PC1. So we send it directly to PC1 without any broadcasting. And the ping is successful. Thank you so much for watching this video.